Okay, here we go. Good morning. Welcome back to my stream. What were we doing yesterday? Oh, yes. Crafting interpreters, and we had gotten up to the point where I could type upside down question marks on my keyboard. Let me just pop out my chat. Get that set up. Okay, I think we're ready to get going. So before I continue with section section 7.2, I would like to try to clean up the error API that we've got. Because right now, every time we generate an error, so I have the string in here. What I think I want, because now every time we call this, we have to call toString on it. So I think if I just change this to str and change this to str and then change this to str, come on, then we can get rid of all these extra toStrings. So let me look for error and parse error. Yeah, so it's everywhere, and I think that, yeah, see, we got all these toStrings on here. So let me see if I can just clean those up. Because it's a little nicer not to have to do that each time. So I'm just gonna, okay, that's that one. What else has it? The interpreter has it. Yep. And then what else? Oh, I want to hit colon, Control P. There we go. Scanner, we did AST printer. Let's do that one. Oh, this one we have error, but we're not using the error function. Okay, that's fine. And then parser. Yeah, we got it here. Oh, and then we're gonna have to clean that up too, right? Because we're passing this in here. Parser error is expecting a string, and so this is taking a string now. Okay. Message string. Oh, for consume, right? So str for consume. So every place we use consume, we can get rid of the toString. Oh, which is only one spot. Okay. So this changes to stir. And does any of this work? Of course not. Oh, yeah, and then I just want to call toString on it here. So this is the only place where toString happens. Everything else just works. Message. And this doesn't need to be like that. What else? This doesn't need to be like that. What else? Okay. Yeah, okay, so I think that's a little bit cleaner. And this warning is from the synchronize function. So I'm not too worried about that. And for some reason my window decided to jump down. Okay, so let's fix that. So get status, get diff. Yeah, so I just changed all these to stirs, and this seems to have cleaned up. Yeah, so this 4 lines collapse down to 1, which is nice because they're shorter now. Okay, so let's commit these changes. Git add source. Clean up error API. Okay, that makes me feel a little bit better. And then the other thing was we were looking yesterday at the interpreter code and seeing if I was thinking, should we try to implement standard ops instead of doing this deconstruction here? And then the other thing was suggested yesterday was to rewrite the object type or refactor that, so that instead of having a separate true and false, we just emulate this thing here, or be consistent with this. So we have num for numbers, we have stir for strings, and so we should have bool for boolean. Right, and that's going to change a bunch of stuff, including this here. And I think doing it this way is probably going to save us in the long run. So let's just try that out. Object bool x. Is just going to be if x, then right bang f true, else right bang f false, right? And then these two go away, and then all the other places where we use true and false have to change. Right, so this becomes object bool not self is truthy, right, and then a comma there, and then these lines go away, and that doesn't work. Oh, because it has to be an okay. Oh, right. So that makes this a little bit less pleasant. I don't know if you can say bool false here. That might not fly. Didn't complain. Oops. I'll remove the semicolon because we're returning the value. Really? Oh yeah, we are returning the result. That's right. Okay, and then this just becomes bool false. So does this. Okay, so that cleaned that up. Right there. This actually, I'm surprised works. We'll have to test it out. And then these work because we're just generating them that way. This code is a little bit longer because this gets stretched out, but oh well. Okay, so git add source, git status, git commit -m refactor bool true false into object bool. All right. Okay. The other thing I was thinking was we can actually write tests for this, right? So the parser and the scanner are a little difficult for me to think about how to write tests for, because identifier calls or at least not the scanner, the parser. That's what I was thinking. The parser, parser calls expression, expression calls equality, equality calls comparison, comparison calls term, and so on. So you get this chain of events which go all the way down to primary. Primary calls unary somewhere, right? But then we go back to expression if we see a left paren. So this is this loop of function calls. So it's hard to write a unit test for a function that calls other functions within its own class, struct, impl. How do you say it in Rust? I don't know. But with the interpreter, right? Each one of these is well, at least the unary one is testable, right? Because it doesn't call anything else. This just calls clone unwrap. This calls evaluate, which might be hard to test, but it's a one line. So I don't know. And then when we get to the binary expert, it might be nice to write tests for. So let me see if we can actually test visit unary expert right now before we get into binary experts. Because it should be straightforward. We create a unary expert, we pass it in and make sure that the object gets returned correctly, or we get an appropriate locks error. And actually we can say what line we're on. I didn't notice this before. So we can actually say expert.operator.line here. Yeah. And that reaches the I missed the G. Okay, so let's try to write a test. For visit unary expert. Test unary minus. So what we need to do is create an interpreter. Right? Then we have to create a unary expression. And the way we do it, we say, it has to be unary expert. So it's expert unary. Oh, we can actually look to see how it was done in our AST printer source main. Right, we did it in here. Right here. Oh, it's box, right? So we have to box it. Maybe we'll box it when we create the... Oh, but we're just passing it into this thing. It doesn't need to be boxed. But what's inside it needs to be boxed. Right, we're just passing the unary expert. Okay, so let's just follow this. So we have expert unary expert operator, which is going to be a token. And we don't have, I think we have token new, right? And then write, I'll just put that like that for now. And then write is going to be box new, expert literal, literal expert, value of some object num 123.0. And that's the sum, that's the literal expert, that's the literal, that's the box. And that's the whole thing. And then we just need, oops, I missed something. That's the unary expert, that's the literal, that's that one, that's, oops. Gotta get this in the right order. That one there, that one there, that one there. Then we need to close this one, and then we semicolon. Okay. Does that get it right? Yes. Okay. Good. For the token, though, let's take a look at our token code. We give it a token type, and we're going to do unary minus. So it's token type minus. Next thing is a string, which is a lexeme of minus, and here's a toString again. That's okay. Literal, I guess we don't, there is no literal, so we can just say none. And the line number we don't care. Let's just say 123. So that creates, so this should create a new token. Now, of course, if I run cargo check on it, it's not going to check this because this is a test. It should be a check test hotkey. I can try running it, but we don't have any certs. Oh, well, I mean, we can at least get it to compile, right? So let's do that. Actually, we can put this in here, right? Because this is not needed by the interpreter yet. It might be, but we can do this. Okay, run tests. Something went wrong here. Oh, yeah, we're not using it, we're not using it, we're not using synchronize. Okay, good. Okay, so this, we now have a unary expert. We should be able to call visit unary expert on our interpreter and have a result come back. So say let result is terp visit unary expert. Unary expert. And then we should be able to assert that is result is okay. And we should be able to assert that result unwrap or okay is equal to some object num of negative 123.0. Right. I think, is that all we have to do? Oh, assert EQ. Let's see. Let's run this test. Nope. Didn't we create a unary expert? Okay, so we got a few things going on. Expected reference expert unary expert. Oh, maybe we don't need to wrap this in this. Okay, maybe that one's that problem. And then this I think we just need to add equality to, or partial equal to the object, right? Block is empty. You might not have meant to close it. I don't know what that means. Am I missing I mean, I'm creating a new interpreter here, right? So this is supposed to be like this. Oh, like that maybe? Is that the bug? Because that one matches there. Yeah, okay. Closing delimiter possibly meant for this. Okay, so I'm still messing this up. This is the sum. This is the close for the num. This is the close for the sum. This is the close for the literal expert, and this is the close for the literal, and then we need one for the box. Oh, okay. Yep. And then this closes that one. There we go. Okay, so that's saved, and let's run the test. Right, this must implement partial equals. So let's open up source object and see if we can toss it in there. Test. Oh, it tested and it passed. Okay, let's just verify. If I make this 124 and run the, oh, I didn't mean to run it. Now I can't kill it. I'm just in a different window here trying to kill the, there we go. I meant to run tests. I wish I knew how to kill a process that was running in the other window source, because hitting Control C does not work. All right, test. Yeah, it failed. Okay, so that means that it actually is running this test and it's checking the value correctly. So that allows us to test unary minus, and we should be able to test, what's the other one? Bang. We implemented bang. So let's write a test for that. No, that's not how you write it. Like this. Test unary not. So M There we go, bang. Let's just make that a bang there. We'll make this a bool. I guess we'll make this false. And then insert it equals bool and true. Right? And then let's try running those tests. And they both test. And they both pass. This is good. So now we're actually writing tests for our interpreter. So this is the stuff we've done already as far as 7.2.4, I guess, was the section we just finished. So now we're ready to dive into section 7.2.5, and we can actually write tests. We can do a little TDD while we're doing this. So the first thing we want to do, we're going to add minus, slash, and star for our binary expr. Right, so onto the last expression tree class, binary operators. There's a handful of them, and we'll start with the arithmetic ones. Right, I mean, this is very similar to the unary one, except we have, instead of just a right, we have a left and a right. And we do it in order here. Right, and we read this yesterday. Did you notice we pinned down a subtle corner of the language semantics? So we evaluate left, and then we evaluate right. So that's what we're doing here. I think you can figure out what's going on here. The main difference from the unary negation operator is that we have two operands to evaluate. Chromos Drift says, cool. Hey, Chromos, how are you? All right, so the first thing we want to do, if we're going to do TDD, or at least a stripped down version of TDD, is we want to write a test for each one of these. So test binary subtraction. Well, we can just say subtraction, right? And I already saw this here. I left out one arithmetic operator because it's a little special. The plus can either add two numbers or concatenate two strings. So we'll get to that. All right, so let's test subtraction. We have to create an interpreter. And then we have to create a binary expr. And we'll just model it after our unary expr. I mean, the code up here. We have a left, which is going to be a box new of something. And I'll type that in a minute. We have an operator of subtraction, which is going to be this token. We can just grab this whole line and put it here. And then we have a right of box new of something. And then we'll just do the same exact thing here. Grab these lines, paste them in, close this. And instead of unary, we'll say binary. And if we're going to subtract two numbers, what are we going to subtract? 15 minus 7, sure. And then that will be a num of 8. Okay, so now how do we create a 15? So that's going to be a literal, right? Let's take a look at how we make literals. We did that here again. Literal expr. Okay, so that's pretty straightforward. We say expr, literal expr, value some object num. Okay, what did I say? 15 minus 7. That closes that. Oop, that's sum. That closes the literal expr. That closes the literal, and that closes the box. Okay, so then right is just going to be that, and instead of 15, it's going to be 7, and that should be equal to 8. Okay, so let's see if this works. Test. Oh, I forgot to rename this. Test, and it failed because we returned nil. So that's good. So we have a failing test. Let's write the code now and make sure it works. So we say object left is self evaluate expr.left question mark. Object right is going to be evaluate the right side. Red green refactor. Yep, that's exactly right. Chroma shift. I'm not a strict TDD guy, but I fake it. Match expr operator token type. Right, I'm just following this code here because we wrote an accessor or a getter method for it instead of making them all public. So if we have token type minus, we have to destructure these things because these are objects. So we have to say if let some, and I'm going to fix this in a minute. I just want to get this working. Object number left is equal to left. If let some object num right equals right, then we're going to return OK of left minus right. I'll just say return here, so I don't have to write excessive amounts of code about success and failures. All right, and if that fails, then we're going to return an error. And we'll say expr operator line. I should write tests for the error cases too, right? Invalid expression, I guess. And then everything else is going to be panic, not implemented yet. Oh, it should be to do. Oh, what am I doing? I was looking at this code and typing it in. That's Java, you fool. All right, so expert. Oh, I forgot to underscore that. This expression has type object. Oh, okay, so it's not an option. It's already been de-optionized. Okay. Oh, right, object. I have to create an object num out of it. Okay, what else? There we go. Okay, so let's see. Run the test. Wow, Unity's test subtraction worked. I'm going to change this one more time. I'll change that to a 7 and run the test. Yes, perfect. Okay. So that's unary subtraction, but you see how annoying this code is to write. So what I want to do is change it so I can just say object, just return left minus right. That's what I want to do. And we can do that if we implement standard ops for object. So, and now that we have a test, we know we can verify that it all works. Well, we have a single test. So let's write standard ops sub for object, and then we can just refactor this code here and make sure it all works. So if I open object, I can just say use standard ops sub. And we're going to add the other ones in there too. I don't know, maybe should I just do star there just to preempt things. Impl sub for object. I think it says you need type. Let's find out. Let's use our the compiler to help us. Yeah, we need a type. So we say type output equals object. Fn sub self and then underscore RHS. I think the other side is right. Is just self. I forget how RHS works, but I think RHS just defaults to self, and then that returns an object. And now what we want to do is we want to only subtract if they're numbers, right? We're casting to doubles here, which could fail. And that would throw a number format exception, or not a number format, I forget what in Java it is. Invalid cast exception, I forget. But we want to say basically this other code, right? If I take a look at the interpreter, we want to destructure it, but I don't want to do it this way because this gets messy in a nested way. So instead I'm going to cheat and use a match. Class cast exception. Thank you, ChromoShift. That's right. Sorry, Chromos Undrift. I keep mispronouncing your name. Apologies. Self and then other. So we just match it as a tuple. And we can say object, if it's object num left, comma, object num right, then this returns an object num of left minus right. Otherwise, anything else is going to be an error. How do we want to handle errors? Because we can't change this to return a result. We can only return an object. So let's create. Oh, I already. Okay, I don't need this interpreter anymore right now. Let's create an error. Arithmetic error. I should call it a class cast exception. And that's what gets returned then. Object arithmetic error. Yeah. And that's the whole of subtraction, hopefully. Does that build? It does not. Of course not. Oh, because I don't have this here. Object arithmetic exception. Panic. Should not be trying to print this. Easy? Oh, it doesn't like that because... Oh, error. Oops. There we go. All right, so that builds. So now we should be able to go back to our interpreter and do what I said, left minus right. But we want to get rid of all of that stuff and just say let result equals, because then we want to see, is it an error? And that's when we return the error. If, oh, semicolon here, right? And then if object result is an object arithmetic error, then we're going to return an error. Expr operator dot line illegal expression else result. Does that build? It does not. Oh, METIC. Oh, okay, result. Oh, look at that. Okay, now we run the test and it worked. Excellent. So test subtraction works doing just like that. Doing it just like that. So we have left minus right. So now we're going to write slash. Oh, we got to write the test first. Let's write the test first. Test division. And 15 divided by 7. Let's not do 15 divided by 7. Let's do 21 divided by 7. And that's going to be 3. We're going to change the minus here to a slash, and we're going to change the minus here to a slash. And then run the test. And it failed. Not implemented yet. Not implemented yet. Oops. Okay. Maybe to do shouldn't say not implemented yet also. To do. Need to work on your code, dude. There we go. Chromos Undrift says, yay, would you consider creating helper functions for creating literals? That's a good idea. The reason I'm hesitating is because the literals are in code that gets, here, I'll show you, source, expr. All of this code here, so where we define the literal expr, is actually code that gets generated. So I can't impl. Oh, I see. In the test. Yeah. So just write a little thing here. That would make things a little bit easier. So fn make literal. Number, I guess. And then we'll just say n is f64. This returns a literal expression. Yeah, that's a very good idea. Thank you, Chromosome Drift. And then we can just copy one of these guys. And just put n in there. And we can just, oh, I guess we can return the whole box, because we always need a box for it, right? Right? Okay. And then we can just look for literal expr here and just say make literal number 3.0. Run the test. Ooh, what did I do wrong? I did something wrong. Because we're definitely boxing up that. We're definitely doing that. What's this 69 is? Oh, it's this line here. Okay. Oh. Do I have to make this expr literal? I don't know if I can do it like that though. Yeah, and that's right. The other thing is, I hit save, but it's not checking the tests because the tests don't exist. Yeah, it's not a type. So how do you return that? I guess I could just have it return literal expr, and then I'd still have to box new expr literal it. Or maybe we just say expr. Yeah, that seemed to work. So we can just throw that in and then just box up some random expr. Okay, let's go with that. And then so let's just replace all our little exprs with those. Oh, this is Boolean, so make literal Boolean. Right? And then so we can just change this here to false, right? Make literal Boolean false. And then this is a num again. Make literal number 15.0. Make number 7.0. And then we have 21. So I'm gonna grab this one here. Put that, oops, there. And then let's just put this here and change the 7 to a 21. And tests. Oops, used more than once. All right, I forgot to change this to left. Oh, damn it. There, jeez. A division failed though. Why? Oh, because I didn't do it yet. Okay, good. All right, so we're getting there. We're getting there. But yes, I agree, Chromos. This is much clearer much easier to read. Left make little number 15, blah, blah, blah. The tokens have a constructor, which is kind of long, but I'll leave it like that. All right. So now what we should be able to do is say in here, what is it, binary? Here's a token type minus. Let's write token type slash. Token type slash left divided by right. Right? And that should fail because we can't divide objects yet. And now we impl div for object. And we need type output as object. And then we just basically clone this code, right? We call it div. We change this to a div and return arithmetic error. That compiles. Let's run the test. And yay, test division works. Okay. Next is star, so multiplication. Chromos asks, so that's operator overloading in Rust? Yeah. All you have to do is, what did I just do? I was trying to go back here. You implement for your type, whatever your type is, you can implement sub, div, mul, or add, and there's a whole bunch of them under standard ops. Actually, we should also do, now that I think about it, we should do not and bang, right? Standard ops. And each one of those are traits, and you just implement the trait. Yeah, type output equals self. And I think there's a way you can do it so you can actually have right-hand side be something other than self. Takov 751, hello. Welcome to the channel. And I forget how to do that part because there is the RHS business that you can do. Add, oh yeah, and then add a sign so for the plus equals operator. So every single operator you can think of. Usually you can generate your own code for range bounds, which is kind of cool. So it's just these. Thank you for the follow, Takov. All right, so what we were doing was star. So let's implement our, oops. All right, so we're going to do test division. No, test multiplication. Quick, what's 15 times 7 off the top of your head? 15 times 6 is 30 times 3, which is 90. So another 15 is 105. And then star. And then star. Right? I don't know if it's actually 105. I can't do it in my head. All right, so that test, if we run the test, it should fail. It fails. Not implemented. Need to work on your code. Let's write our code. Token type star is left times right. And I run the test again. And now the trait doesn't exist. Must implement a mul, which we can do. Yeah, see how it says mul, RHS, right-hand side is RHS. So you can actually have it be a different type. You can multiply an object times a number, for example. So we did division, let's do multiplication, mul. That all checks, and multiplication works. All right, that's good. So we did these. So I left out one arithmetic operator because it's a little special. Because we want to either do number plus number or string plus string. And we can do that also in our operator overloading, right? Because we're just passing in numbers. So we can say copy paste, test addition. plus, 21 times plus 7 is 28. Oh, that also meant that I got the 105 correct. How about that? So run a test, and it fails because I haven't written the plus. Token type plus is left plus right. And we don't actually have to have these as separate cases here. We could just say left plus right and have it do the right thing. Let's do the test, and now we have to implement add. Okay? So, oops. So what I'm going to do is I'm going to do these in two steps. First, I'm going to do these numbers. So there's plus, and we're going to change this to add. So that should work. Test. And that works. Test addition works. So next, I want to test concatenation. So instead of creating literal numbers, now we're going to create a literal string. And it's just going to be these 3 lines. Actually, copy all 4 lines. Why not? And then we're going to make this sum stir s dot to string. And down here, we're going to say make literal string. Hello, comma, space. And string world. Bang, comma. Should be okay, and we should be resulting in stir hello world. Bang. I don't know if we can compare like this, but we'll see. Oops, did I mess up my string concatenation code? That's that, that's that, that's that, and that's that. Oh, not this, not there. Here. There we go. Okay. Okay, that checks. Run the test. Expected string found stir. Oh, right. I have to toString this. Test. Assertion failed. Result is okay. So that's good. So it's actually, we just tested the fact that we can detect arithmetic errors. But we should make that a formal test. And we should have made it a formal test before I wrote all this code. But anyway, so let's do string concatenation. So instead of num left and num right, we have stir left and stir right. We want to make this a stir. And this might be a little more complicated, right? Because we're going to have to, well, we don't have to brace it in because it's going to go too long, right? We have to make that a format statement in order to concatenate them. So I think it's going to put braces on there anyway. So let's do that. Format, bang, and just left, right. Let's see what it does. Oh, it did. Okay, it fit the whole thing. Nice. Coding package says, what music are you playing? It's nice. I'm using Pretzel. Let me see what's currently playing on Pretzel. Pretzel, hello Pretzel. It says the Tin Roof Graffiti Abstraction. I'm just used the chill station on pretzel.rocks. I don't know if you're familiar with Pretzel Rocks. But they've got a ton of Twitch and YouTube safe music. And I upload these, the VODs to YouTube. So I turn on the YouTube safe music and I just play. They have a whole bunch of tracks you can play, which are nice. And this one, oh, sorry, I missed it. It was called Tin Roof Graffiti. Where is my recent list here? Yeah, Tin Roof Graffiti Abstraction. I'm not familiar with the artists. Abstraction is the name of the track. Oh, 2-hour track challenge. Huh. Yeah, this is it. Tin Roof Graffiti by Abstraction. All right. So this should run the test, and it worked. Okay, string concatenation works. We should write a test for the arithmetic errors, right? If we try to subtract a string from another string, it should give us an error. So let's write a really quick test for that. Test fn test arithmetic error for subtraction. I like really long test names. And then we just have to basically, where's my subtraction test? Here we go. And I just change it to, subtract a Boolean from something. Make literal Boolean true. And we should get is error. And I don't know what the result should be other than error. I don't think I care about the actual error text. Okay, so that worked. All right, so we have those tests. Nice. And we've done this part here. The plus operator can also be used to concatenate two strings. To handle that, we don't just assume the operands are a certain type and cast them. We dynamically check the type and choose the appropriate operation. Okay, and then the way we did that in Rust was just to use the match statement to determine what the types were. You can see that down here. If this tuple ends up being two nums, we add them. If the tuple ends up being two strings, we concatenate them, and then we're done. We could have defined an operator specifically for string concatenation. That's what Perl, dot, and Lua, dot, dot, Smalltalk, comma, and Haskell++, and others do. I thought it would make LOX a little more approachable to use the same syntax as Java, JavaScript, Python, and others. This means that the plus operator is overloaded to support both adding numbers and concatenating strings. Even in languages that don't use plus for strings, they still often overload it for adding both integers and floating point numbers. Ah, that's true. Next up are the comparison operators. We have greater, greater, equal, less, less equal. All right, so should we do test TDD again? I think we should. Because this is just going to end up being, I'm not going to write it now because I want to write the test for it. Token type greater is going to end up being left greater than right. That's all we're going to do. And we're going to overload the operator for greater than. So test. And test greater than. And all I'll do is grab this, the binary expr. I guess we should be testing it all directions, right? We visit the binary expr, we say it's okay, and then we want to say that we got a false. Right? Because 15 is not greater than 10. Oh, sorry, 15 is greater than 10. That's not true. Oh, God. All right, and then we want to test true. And then test greater than false. And I guess we can just make them equal and make sure that it's not greater than. I should write all three directions, right? 11 Wyverns, hello. And thank you for the follow. All right, so run test. It should fail. Cannot apply unary operator. Yeah. Oh, how am I writing Grather? G-A-T-H-E-R. Greater. Okay. So what's it saying here? Cannot apply unary operator. I'm not trying to apply a unary operator. I'm trying to assert. Oh, I must have messed up a... What did I mess up? There must be a brace or something I missed. I don't see it. I don't see it. Cannot apply unary operator bang to type option object object. It's like it's not seeing the macro there. So I must have. Let's do it one more time. Let's blow that away. Let's blow that away. Let's grab multiplication. And I'll just change it to greater. And make sure it works. Yep. Okay. And then we just change this to, we'll leave the 15 to 7. We'll change this to greater and greater. And run the tests. Okay, that worked. Right, because greater than doesn't exist yet. But we have to change this to object bool true. Yeah, there must have been an extra bracket somewhere along the way. Okay, so then we can remove that code. And that fails because we haven't written partial org. Okay, so this is where we write the next operator overloading thing, which is going to be, well, that was wizard spain. Rust standard ops. No, standard compare. Oh, Quantum Garden. Sorry, I missed your message. Hi, I'm planning to go through crafting interpreters in the future. Yeah, no, it's good. It's good. It's really good. What I'm doing is slightly different to what they were expecting me to do. And I'm going through this book for the first time, actually, but I'm porting it to Rust because I do Rust on my channel. And it's a really well-written book. I actually bought the hard copy, but I'm going through it on the web here, and it's really nice to explain it very well. It's very detailed. All the concepts are here, and I've been enjoying it a lot. So I do recommend it. Right, so now we have to go back into our object code and implement standard compare greater. Traits. Partial org. So we have to implement partial org for, here we go, this one. And I think we just need to implement partial compare, right? We don't have to do each one of these. The LT, LE, GT, and GE methods of this trait can be called using those operators. Methods of traits must be consistent with each other. But I thought there was something where you could just write partial compare and it automatically does the rest for you. And I was hoping it would say that here. This trait can be used with derive, but we can't do that. How can I implement partial org? Here we go. Yeah, so they only implement partial compare. They don't implement these four. So I wonder if these four are implemented in terms of partial compare. Let's see. take a look at the code. Yeah, so these are already implemented, right? You can override them, I guess. But if you don't, then they just call partial compare. Okay, so we just need to write partial comp. And we can just steal this boilerplate here. Sorry, partial ord. And we can steal this boilerplate. So let's do that. Let's pull this in. Center compare. And then impl partial ord. And this should give us all of the things. Fn partial compare self and other self returns an option ordering. And the ordering is going to be standard compare ordering, I think, is just less, greater, or equal, right? Here it is. Less, equal, or greater. Okay. So, okay, you know what we're going to do is we're going to just say none and see what happens. What are we missing? This was found to be of type object. Oh, this is returning a Boolean. Oh, right. Right. We can't just do that. We actually have to say object bool. There we go. Quantum Garden says, is Rust that good? I saw a statistic that Rust developers tend to stay in Rust more than in most other programming languages. Rust, I enjoy Rust a lot. I'm a C programmer by day, and I'm trying to learn Rust, and I figured, well, why not learn it in front of a Twitch audience? Which sounds silly when I say it out loud, but I thought it would be a lot of fun to just learn Rust and go through this. I've done a bunch of Rust on stream now, and I've been, it's a very nice language to work with. And Quantum Garden says, what was the hardest thing in interpreters for you so far? According to people yesterday in chat, I haven't hit the hardest thing yet. Apparently the hardest thing is closures and environments. So we're gonna get there. I'm sure we'll get there soon. All right, so we don't want to return none, right? We want to actually compare these guys and return less, greater, or equal. Now the only catch is I can't. How do I return an error? What if your partial ord says no, we can't do that? Where's my traits? Is there a way we can return something that says, oh, that didn't work? Oh, Quantum Garden, thank you for the follow. So if I run this now, it fails. Oh, it fails because I got my test backwards. Interpreter, there we go. Oh no, I got the test right. This failed because it came back with false. So I guess if we return none, which is what I'm doing now. If we return none, it ends up being a false value. So I guess we can just break it down here. Match, self, other. Object, num, left. Object, num, right. And then we're going to just say left, partial compare to right, I think is what we need to do. And then anything else is just going to return none. Tell me that works. No, it didn't complain. Tell me it tests. It tests. Okay, so greater than true works. Kiwa says, I wanted to learn a low-level language to understand more abstract concepts. Started with C++. Do you recommend Rust or C or keep with C++? So that's, unfortunately, I'm not the right person to ask because I've tried C++ many years ago, and I tried it several times since then, and my brain and C++ don't get along. We agree to disagree on how to write code. Let's put it that way. I've been doing C for many years, and that's, like I said, that's my day job. So I'm really good at C, and my brain is kind of molded into the C shape, for example. But Rust is a more modern language than C and has a lot fewer issues in terms of corner cases and undefined behavior and things like that. You know, if you're gonna start with systems programming, I know that Rust, they just released an operating system in Rust, didn't they? GitHub, I think it's called Hubris. Yeah, Oxide Computer Hubris. So there's a whole operating system that's a microcontroller operating environment. Sorry, not an operating system. For embedded systems, it's completely written in Rust. Well, 99.1% of it is written in Rust. I bet you the rest is like makefiles and shell scripts and things like that. And then it comes with a debugger too called Humility. So, which is also all written in Rust. Well, 99.9% written in Rust. So, yeah, I mean, it's a great language, and I've been enjoying it, and I would recommend it, is where I'm going with that. Okay, so this does all of the compares. We only have to write this one, and we should get this one line, sorry, and we should get automatically less than or equal to, greater and greater than or equal to. So all of these remaining tests should be straightforward. Let's copy, paste, and change this to a false, and then we'll just swap these, or I'll make this a 17, and this should be false then. And if I run the test, that test should pass. Yeah, but I don't want to write 2 tests for every single operator. So let's write greater than or equal to, because I think it, testing 1 tests them all. Well, equal to. That should be true. And if I run that test, it should fail because we don't have that operator implemented. But implementing that operator should be just this, equal, and then change that to an equal. That checks, and it runs. So if I do strict TDD, I should also write 2 more tests to make sure that it correctly checks for greater than and correctly checks for not greater than. I'm getting lazy though. So 2yy, paste, oops, and make this less. What do I do? And then this becomes less than, and this becomes less than. So those should be those 4. And this should build because we don't have. Oh, Keyboss, thank you for the follow. If you want to learn, so you're looking to learn more complex concepts, and yeah, actually, so Rust is what makes Rust a little bit better than C right now is that it's got a standard library that has all sorts of things that C doesn't have in its standard library. For example, hashing. That's the first thing that comes to mind. Hash sets and hash maps exist in Rust as part of the standard library, and those don't exist in C. So if you want them in your code, every executable you create has to implement its own. Has to have a copy of its own implementation, which is kind of annoying. Okay, so we did all of these, and now we want to do equal. So we actually going to write an is equal, or should we do continue with the operator overloading? And I think we need to continue with the operator overloading. So token type bang equal object bool left equals right. Oh, bang equals right. And then we didn't call it equal, we called it equals in our code. Right? That compiles. I should have written a test first. I didn't. Let's write a test. EQUALS. Thank you. F7 R5. This should be true. And we change this to equals. And there, run the tests. So test equals works, and then we'll test bang equals. Okay, run the tests. Okay, so those all work. And we didn't have to write. That's interesting. Oh, is this messed up now because we're not doing this right? Did I do? Yeah, I derived partial equal. I wonder if that's going to actually work. I mean, it did work, right? But what happens if I pass in two strings? Make literal string hello, and make literal string hello with an X. And this should not be equal. I'm going to leave that as true and see if it fails. It did fail. Okay. So we automatically also have string comparison. So what are they doing here? They're saying if A is null and B is null, return true. Ooh. Well, that's going to work, right? That's going to work because we're going to test our nil. Test equals nil. Oh, now I have to write make literal nil. Let's just copy this and change this to nil. We don't need to pass in anything. All we're going to do is pass in nil. And we don't need that. Okay? Equals nil did not work. Oh, because oh. Yeah, that should have worked, right? Oh, I made this false. True. There we go. Yeah, okay, so that works. So we have this. If A is null, return false. Oh, interesting. Interesting. So we need to fix that in our partial ORD. We say object nil and anything. We're going to say if O, I guess. So anything that has O, if O, so we're going to return here if O is equal to object nil, we're going to return true. We'll say, oh, sorry, option equals, sum equals, else none. So it's always false. Oh, and I forgot the arrow. No, we can't compare. No implementation for, oh, I can just put an ampersand there. Okay. Equal. There we go. Chromos says, can you generify the make literal x functions? Maybe. I'm trying to think. I'm pausing because I'm trying to think, and maybe? It would mean passing in the object, right? Make literal O object, right? And then just return a box expr. And then this would be just value of O. But then we would have an issue with copy. I think this will complain about doesn't implement the copy trait. Oh no, it didn't. Okay. I don't know. I think it'll make the code. Let's take a look at let's change one of them and see what that looks like. So this would just become make literal, and then I'd have to say object num 15, right? And then this would become object num 16. Yeah, I mean, it works. It works. Is this easier to read? Maybe. Oh, and then for this, we'd have to do the toString. But we can just call that, right? Make literal object stir. Yeah, so those all stay the same. But we can get rid of make a literal male, make a literal number, make a literal boolean, and change this here. Okay, yeah, that might, I'll go along with this. And then this becomes object bool false. Object num 15. Object num 7. Right? Almost done. Almost done. There's the strings. There's arithmetic error. Okay. Oh, I thought I was almost done. But I think it cleans up the code, so that's why I'm willing to go through this. And every so often I'll hit F1 and end up with that. How many are left? Oops, this one here. D-loop, hi, how are you? Chromos says I unbind F1 in Vim. Yeah, that's a good idea. Although I think this is my operating system is bypassing this. I'm on a Mac, unfortunately with the touch bar, which my next one is not going to have a touch bar. I can tell you that right now. So there's the strings. There's the, oh, make literal nil. Object num. Okay, I think we're done. Let's see, what did I miss? Doesn't like this because I didn't put an extra one of those there. Okay, so that works. Run the tests. Test pass. Okay, we're good. So I think we have this equivalent here. Right? We're checking to see if they're both null. Well, let's take a look. If they're both nil, then we return equal. If the first one is nil and the second one is anything else, we return none, which always forces it to be false. Otherwise, we'll do we'll do the partial compare of the two nums. Otherwise, it's false. It's always false. I don't think it's exactly the same as what they've got here because this is just the equal case and this is the every case. But I think it's close enough for our purposes. Yeah. So these are basically the same as the arithmetic ones. The only difference is that where the arithmetic operators produce a value whose type is the same as the operands, the comparison operators always produce a Boolean. Yeah, and we saw that with our other code here in the interpreter, where we have to cast them all to Booleans. The last pair of operators are equality. We did those. Unlike the comparison operators, which require numbers, the equality operators support operands of any type, even mixed ones. Oh, okay, so we're going to have to implement that. You can't ask locks if 3 is less than 3, but you can ask if it's equal to it. Right, and so we're cheating and using this. So we're going to have to we're going to have to think about the right way to go about doing this. Because we want to be able to compare, see if strings are equal to each other, right? So maybe we can do that, right? Boom. Stir. And stir. I think Rust supports that. Oh, right. We have to make this an ordering. Rust string compare ordering. I guess we only want to do this for equality though, right? And we already have that for equality. Right? With our partial equal, it's already there. Let's write a quick test for equal string. I think I have not equals for strings. Right? Test equal strings. It should be false. Make this a test not equals. And just make sure we can write a test for string equality. Does world equal world, for example? And it should. And it does. Okay, that's good. Pedota Palman says, does partial compare return option? And it does. Yes, it does. If we look at the partial compare, where is it? So I'm using F64s, but they all do the same thing. They all return option ordering. We can take a look at the implementation real quick. So they made a macro for it. It returns sum, self compared to other. And here's compare, less, equal, or greater. And I don't know how it does this with floats, but I guess, you take your chances when you compare floats equal to each other. Which kind of is going to be, it might be a problem in future code with locks, because I think it's expecting them to be, if there is no fractional part, just treat them as integers. And you might have a fraction of like, one could be like 15.000001 and the other one is 15.0, and those are not equal in float. But this is obviously because of some sort of rounding error, and so you want them to be equal. So I don't know. Is there a locks test suite for locks implementations to check themselves against? That would be nice. If it had a bunch of locks code that we could just pipe through our interpreter and say, is it doing the things it's supposed to do? Is it checking all the corner cases? All right. But we have test run. We got through section 7.2. Like truthiness, equality logic is hoisted out into a separate method. This is one of those corners where the details of how we represent locks objects in terms of Java matter. We need to correctly implement locks' notation of equality, which may be different from Java's. Chromosome Drift says, if there's not a bunch of locks code, I guess it doesn't matter as much if it's compliant. That's true, although it would be really nice as a corollary to this book to say, okay, here's a test suite. You've written your own. Here's a test suite. Try it out. Does it work? But you're right. I mean, locks is a toy language used for this book, the purposes of teaching somebody how to write an interpreter. And, if you don't get 100% correct, nobody's going to care. So we need to correctly implement locks' notation of equality. Fortunately, the two are pretty similar. Locks doesn't do implicit conversions in equality, and Java does not either. We do have to handle the nil-null, especially so we don't throw a null pointer exception if we try to call equals on null. Otherwise, we're fine. Java's equals method on Boolean, double, and string have the behavior we want for locks, and that's it. That's all the code we need to correctly interpret a valid locks expression. But what about an invalid one? In particular, what happens when a sub-expression evaluates to an object of the wrong type for the operation being performed? Okay, so we sort of already have that. And I kind of did that just to get the code to compile. I'm throwing this arithmetic error out of our code just to show that we can test for illegal expressions, but we should do it the locks way. What do you expect this to evaluate to? 0 divided by 0 is equal to 0 divided by 0. According to IEEE 754, which specifies the behavior of double precision numbers, dividing a 0 by 0 gives you the special nan value. Strangely enough, nan is not equal to itself. In Java, the double equal operator on primitive doubles preserves that behavior, but the equals method on a double class does not. Locks uses the latter, so it doesn't follow IEEE. These kind of subtle incompatibilities occupy a dismaying fraction of language implementers' lives. We could simply not detect or report a type error at all. That's what C does if you cast a pointer to some type that doesn't match the data it's actually being pointed to. C gains flexibility and speed by allowing that, but is also famously dangerous. Once you misinterpret bits in memory, all bets are off. Few modern languages accept unsafe operations like that. Instead, most are memory safe and ensure, through some combination of static and runtime checks, that a program can never incorrectly interpret the value stored in a piece of memory. All right. So let's get this committed. We made a lot of changes, right? Through our interpreter, we added all of these operators. yeah, and we refactored this a bit, and we have all the tests we wrote for the operators we added, and then we extended our object. We threw partial equal up here, and we did all the operator overloading, and then we finally did the partial ORed. Section 7.2 operators. Chromos says someone implemented locks and locks. Okay, that's cool. Copy link. Oh, I don't want to use that one. I want to use this one. Locks interpreter implemented in locks. But so locks doesn't have. Okay, yeah, it must have enough in it. This is very cute. Oh, next, locks doesn't have a way to read input. Okay. So we have getC and character. All right, that's a minimal file input, right? But it sounds like it's just standard I/O instead of opening files. Which is so. This is cute. This is cute. Pedota says get C-M loads of changes. Yeah, loads of changes exactly. And I have about a half hour left, so let's see how far we can get into runtime errors. So this might be the end of the coding section for today, because this is talking about runtime errors, and we're already doing checking operands. Right? We're already doing that. But let's see how locks describes it. I was cavalier about jamming casts in whenever a subexpression produces an object and this operator requires it to be a number or a string. Those casts can fail. Even though the user's code is erroneous, if we want to make a usable language, we are responsible for handling that error gracefully. It's time for us to talk about runtime errors. I spilled a lot of ink in the previous chapters talking about error handling, but those were all syntax or static errors. Those are detected and reported before any code is executed. Runtime errors are failures that the language semantics demand we detect and report while the program is running, hence the name. Right now, if an operand is the wrong type for the operation being performed, the Java cast will fail and the JVM will throw a class cast exception. Right, that's what Chromos found or told me about earlier. That unwinds the whole stack and exits the application vomiting its Java stack trace onto the user. That's probably not what we want. The fact that locks is implemented in Java should be a detail hidden from the user. Instead, we want them to understand that a locks runtime error occurred and give them an error message relevant to our language and their program. The Java behavior doesn't have one thing going for it, though. It correctly stops executing any code when an error occurs. Let's say the user enters an expression like 2 times 3 divided by negative muffin. You can't negate a muffin, so we need to report a runtime error in that inner expression. That in turn means we can't evaluate the divided by expression since it has no meaningful right operand. Likewise for the asterisk. So when a runtime error occurs deep in some expression, we need to escape all the way out. We could print a runtime error and then abort the process and exit the application entirely. That has a certain melodramatic flair, sort of the programming language interpreter equivalent of a mic drop. Tempting as that is, we should probably do something a little less cataclysmic. While a runtime error needs to stop evaluating the expression, it shouldn't kill the interpreter. If a user is running the REPL and has a typo in a line of code, they should still be able to keep the session going and enter more code after that. Detecting runtime errors. Our treewalk interpreter evaluates nested expressions using recursive method calls, and we need to unwind out of all of those. Throwing an exception in Java is a fine way to accomplish that. However, instead of using Java's own cast failure, we'll define a locks-specific one so that we can handle it how we want. Before we do the cast, we check the object type ourselves. So for unary minus, we add check number operand. So the way we're doing it here in Rust, instead, is we will return an arithmetic error from the subtraction operation directly. That's what we added to our, like if we do a subtraction, if they're not two numbers, we just say that's an arithmetic error. McEasy, thank you for the follow. So we're doing this already, and we're throwing the error directly from here. And this is Rust's equivalent of throwing an error, just returning a LOX error. I don't know if I should make this a special runtime error, because this is passing the whole token in as the runtime error rather than just the line number. And I don't know if that would be significant. Let's take a look at our error class. The error does have an optional token, so we could just generate, so parse error takes a token, and then we just clone the token. So I could just make a runtime error. I still haven't figured out what this location business is all about. It gets used here. All right, so we can make it. We can have runtime errors different to parse errors, but it's exactly the same. Right? It's just a token. Oh, this takes a token. Oh no, that's check number operator. It takes a token and an operand. Oops. Runtime error just takes a token and a message, which is exactly this. But I don't want to call it a parse error here, right? What I'll do is I'll make a runtime error as a separate thing, and then we can, if it turns out we need to do something different, we'll just do it. Right, it's exactly the same. Except it doesn't work. Oh, right, because I need to give it an actual operator, not a line number. There we go. Okay, so this works. Unlike the Java cast exception, our class tracks the token that identifies where in the user code the runtime error came from. As with static errors, this helps the user know where to fix their code. I admit the name runtime error is confusing since Java defines a runtime exception class. An annoying thing about building interpreters is that your names often collide with the ones already taken by the implementation language. Just wait until we support LOX classes. Okay. Right, and then greater than equal to, less than or equal to. So we don't have to do all of this because we did it inside our... Oh, so that's interesting. So this is saying we can only do... these for numbers. And I kind of left it up to... So we can't throw an error. Using this way of doing things, we can't throw an error if we're not comparing numbers. Right? Because if this is a string and this is a number, this expression will return none the way we have it implemented, which results in false for the resulting object. Which means it feels like we did the comparison and then determined it to be false, and then we did not run into an error. So we don't have the equivalent of this because of the way I did things. Do we want to... I mean, if we're going to be a conforming interpreter, we should figure out how can we do this. Is there a way we can do this? let me try this. Rust implement return error. Generate error from partial ord. Partial compare. Yeah, is there a way you can you have to implement partial equal first, okay. I'm just looking here, comparisons to different types, right? Here's where you have the right-hand side. But what if you fail? What if you're giving it two different things that you want to say, oh, you can't compare those two things? And I don't know if there's a way to do that. Let's try that. Error in derived partial ord for structs. No, that's a bug. Yeah, if I return none, I was hoping none would result in some sort of an error. Yeah. So, I mean, I think when we return none, that's not going to cause this to fail. Chromos. I think it just means that it will always result in a false result. Right? If I just do this. Oh, I already have it returning none. So let me try. What did I do before? I had a test here which compared, yeah, subtracting 15 and true, but I didn't try a test that did a comparison of 15 and true. So let's try that for greater, maybe. Let's see what this does. It failed. Because it's not an error. It returned okay. It should have been an error, but it returned okay. And I don't know how to make that an error. Because this, when we ran this, we did a 15 is greater than some string or Boolean. And this, the greater than partial compare returned none, which resulted in this returning false. All right. I'm going to have to think about that one. And we'll worry about that another time, I guess. I'll have to do some Googling. Oops, I broke it again. Oh, is okay. There we go. Okay. Object bool none is false. Okay, so let me clarify. Object bool none should not even compile. So I don't think this is returning none here. I think what's happening is the partial compare. Let's take a look at the source for partial compare. I'm running left.partial compare to right. If left is a number and right is a number, then we go through this line of code here, and it's going to return a sum less than, equal, or greater than. If we come through here, we're going to see it's not nil and not 0. The first one's not nil, it's a number. So we come down here, we return none. If partial compare returns none, then the greater than expression resolves to false. So we're saying object bool false. So, and I don't see any other way of returning, because ordering only has those 3 options in it. Less than, here's equal, yeah, less, equal, or greater. Those are the only 3 options. There's no, oh, you can't compare those. It always compares. To one of those 3. And I don't see a way to tell it, oh, you got to return a failure case. And there's no failure case. I'll research it offline. And maybe there's an answer for that, but I don't know. Okay. So here's check number operands. We don't need that because we did that as part of the partial compare. Operands must be numbers. I have illegal expression instead. That's okay. The last remaining operator, again the odd one out, is addition. Since plus is overloaded for numbers and strings, it already has code to check the types. All we need to do is fail if neither 2 success case matches. Oh, yeah. All right, we already have that. If you have 2 numbers, we sum the numbers. If you have 2 strings, we concatenate the strings. Everything else is an arithmetic error, and we handle that case here. So we're good. This gets us detecting runtime errors deep in the innards of the evaluator. The errors are getting thrown. The next step is to write code that catches them. For that, we need to wire up the interpreter class into the main locks class that drives it. Okay, and so this will be a good place to start tomorrow's stream with section 7.4. So I don't think we did much. I think maybe I added a test. Oh, yeah, and then I added the runtime error. Git add source, git commit -m, added a test, and runtime error to the error API. Okay, so I think we're good for today. We're going to call it a stream. We did a bunch of stuff. That's good. We got the operators working, and now next is going to be the fun stuff where we actually hook it up to our command line. We can actually type in expressions and interpret them. That's going to be wild. And meanwhile, like I said, I will look offline to see if there's a way that we can get partial compare to return errors if we're comparing things that are not comparable. Yeah. All right, we will do that tomorrow. Or I'll look at it offline, and then I'll if I find it, I will talk about it tomorrow. Okay, that's it. That's the stream. Hopefully 7.4 will be a lot of fun. And I will see you tomorrow. Take care, everyone.